Hey, hope you're all having a really good weekend right now. Trying to get some filmed content put out a little bit. I've been wanting to do this test for a while. I just haven't had time, or sometimes I'll have time, but then my energy levels are low and I don't feel like I can produce something of quality. And so I don't get something filmed. I've not had a chance to do this test yet, and I wanted to go through it for those of you who might be starting your preparation for next year's AMC 8. I am going to do a stopwatch. This will be my first time going through the problems. I'm going to try and explain, so I might not finish in exactly 40 minutes, but it'll give you an idea of how quickly you can think about and process some of the information. What I may do, I'll kind of make a decision in the moment. I may solve a few and then pause the timer and go back and add some explanation to the various things. You can also ask questions in the comments and you can request that I add more information to what I did or why, and I'm more than happy to help with that. Obviously, when I have time, I can't answer every comment immediately. If you're interested in classes, by the way, I do teach classes. I also have a live stream on Saturdays. The live stream is a little bit more than $4 an hour. So it's very inexpensive and it gives you a chance to hear lectures just like this one, albeit probably in even more detail. The live streams go for 1.5 hours each, and there's four of them every month currently. They're on Saturdays from 3:30 to 5 Pacific. Beyond that, I also have a lot of group classes that you're welcome to join. Reach out. You can also ask for a free consultation, and I'll help you design a self-study plan at no cost just to help you out if you don't have the time or don't want to take classes elsewhere. I just do that free of service if I have the time to do so. So anyhow, hope you enjoy this. Let's get started on it. I'm going to hit this stopwatch timer and let's get going through it. Um, the eight-pointed star shown in the figure below is a popular quilting pattern. What percent of the entire 4x4 grid is covered by the star? So we've got a 4x4, so it's definitely 16. You've got four right here. This is a half and half, which is one, two, three, four. So you have four plus four, it's 50%. Doesn't look like 50%, does it? Number two, table below shows the ancient Egyptian hieroglyphs that were used to represent different numbers. So this 30 and 2 is what it looks like. They say it's 32. This makes sense. We're not multiplying, just take the numbers. So 10,000, that's 100. There's four of them. So 10,423, it's B. Let's go down here. Buffalo Shuffalo is a card game in which all the cards are distributed evenly among all players at the start of the game. When Annika and three of her friends play, each player is dealt 15 cards. Okay, so how many? That's 3 times 15 is 45 total cards. It then says if two more friends join, so 3 plus 2, 5 friends, then you're going to distribute 45 over 5 is 9. But hold on, make sure. All players start the game. Annika, that's this is a problem. Okay, so be really careful with stuff like this. This is probably a common error for a lot of people. 9 is a trap answer. Annika and three of her friends. So it's actually going to be 4 times 15 is 60. And then you're going to be able to add two more to four. So there's six people now. 60 divided by 6, 10. 10's the actual answer. Just didn't trust spider sense tingling kind of feeling. Lucius is counting backward by sevens. His first three numbers are 193, 86. So his first three. So you could call this term two, and I've done -7 one time. So if I want the 10th number, then that's like the term 10. I would do -7 9 times. 9 times 7 is 63. 37 is what I call the algebraic complement. The answer is B, 37. If you want to learn about algebraic complements, reach out, try one of my classes. They're free to try for the first lesson. So Betty drives a truck to deliver packages in a neighborhood whose street map is shown below. Betty starts at a factory labeled F and drives to location A, then B, then C. So 1, 2, 3, 1. Okay, so hold on. So she starts at F actually. A, B, C before return. What is the shortest distance in blocks she can drive to complete the route? Here's the thing. No matter which way you go for F, if you do this, it's not different. It's always the same. All we have to do is count the path. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. All paths that do that are the same as long as you don't turn away from your destination, meaning from here, you don't like go over here for some reason, okay? So 24 is the answer there. Keep going. I don't know, I don't know how you pronounce that. Writes these numbers. After he erases one of the numbers, the sum of the remaining 4 is a multiple of 4. So currently we have a sum of 5 times the middle number, which is 85. That's because that's the average. So if he's going to erase one number and have a multiple of 4, we could do guess and check until we find it. Take away 15, and actually it's not that bad. Take away 15, you're at 70. Take away 16, you're at 69. Here's 68. Answer is going to be 68. There's other methods. I'm sure I could do it with remainders as well. I'll go over that more later in a little bit after I get to 10. On the most recent exam in Professor Zoshi's class, this happens, whatever that is. How many students earned a score of at least 80%? So this is at least 80, all 50. Now, when it says at least 85, these 27 are included in that 50. All of these terms are at least. So these 13 are included in that 27 and so on. So 85 or above is 27. 13 is part of that and less than 90. So I don't want any of these 13. I want 50 minus 13, 37. Second time we've seen 37. Number 8, Isaiah cuts open a cardboard cube among some of its edges to form the flat shape shown on the right, which has an area of 18. Well, there's 6 squares. 6 times 3 is 18. So each square is 3. So a side length is root 3. What was the volume of the cube? So he cuts open a cardboard cube. So it was originally a cube, and the edge length of the cube is root 3, and root 3 cubed is 3 root 3. Clear, clear, go. Number 9, Ningley looks at the 6 pairs of numbers directly across from each other and on the clock. She takes the average of each pair of numbers. So like 10 would be 5, 8 would be 4. This is 18, it's going to be a 9. You're probably doing all the numbers from 4 to 9. So 11 and 5 is 16. So you cut that in half, you get 8. Here you get 7. Here you get 6. So you have all these numbers. Now, what was the average of these? So you've got, 10 and 15 and 5 is 39. So this is 20 right here with those ones, and that's 10 more is 39. 39 divided by 6 is 6.5, 6.5b, clear, go. Next one. In the figure below, ABCD is a rectangle with sides of length AB equals 5 and AD equals 3. So this is 5 and 3. Rectangle ABCD is rotated 90 degrees clockwise around the midpoint of side DC. Since that's 5, this is 2.5 and 2.5. But understand that was also the midpoint of AD, so that's also 2.5. So now we have 2.5 by 2.5. Great. What is the total area covered by the 2, not shaded region, the 2 overlapping? This is just like Venn diagram. Left circle plus right circle minus their common intersection. Same thing. So you're going to have 15 plus 15 minus. The square of 2.5 is 6.25. There's a trick to that. We can cover it later. I'm going to add 8.75 to get to 15. This plus this. This plus this is 23.75D. So we'll pause here for a moment. And I just want to add that's 644 in the first 10. I want to add a couple of thoughts just to kind of explain some details on these. On this one here, how does the Venn diagram formula work? You can think of this as a little region of A, B, and C. And if I call this big circle A, let's call it something different. Let's call it like D and E, whereas D is equal to the regions of A plus B combined, and E is equal to the regions of B plus C combined. So the way that you would do this is if you added the D and the E, D plus E, you're going to get A plus B plus B plus C. But you've added this B twice. So if I only wanted the total region, A plus B plus C, I'm going to subtract that B one time, which is their overlapping region. So it's D plus E minus the intersection. This symbol means intersection of D and E. Union is a U shape. Intersection is an upside down U. Intersection means where they overlap or what they have in common. So you treat it almost like area. If I add the area of this circle plus the area of this circle and I subtract this, why? Because I've included it twice and I only want it once. Then I will get the combined area. It's also able to be extrapolated to probability. If I did the probability of D in a different problem, but same concept, probability of D plus the probability of E minus the probability of D and E, and that would give me the probability that D or E occurs. D or E is the union. Union is also in probability. It's used for or, and this is used as and, meaning I need both of them to occur here. So it's very much the same thing in all of these scenarios. Now, this is not actually a Venn diagram, but if you understand the concept of Venn diagram, this square has been included in both of them. And so we have to subtract it once. This is how we take ideas that are not perfectly fitted to the problem and we use them anyway because we can see how it's essentially the same exact concept. Let's go up here. Anything else? Not much to add to this. I was curious when I did it, what is the sum of the numbers from 1 to 12? It's the average of the first and last times the number of terms, so it's 78. If you divide 78 by 12, that's also 39 by 6. I would not have come into this problem with the knowledge that the average of the averages of those numbers is just the average of all 12, but it's a very interesting thing. You might explore this after this video and go try other similar situations. What if we don't start at 1? Does it still work if I go from, say, 5 to 15? Actually, that would be 11 numbers. Let's say you do 5 to 16. Go see if it does that. What if you group them in groups of 3? If you averaged, let's say, 5, 6, and 7 and found their average, maybe make it not 16 numbers then. Let's make it, or not 12. What is it right now? It's 12 numbers. That actually works good because you're going to get 4 groups of 3. Go explore this a little bit after class, after this video, and see if you could prove how is this working? Why is the average of these 12 also equal to the average of the averages when I do cross pairs? What if we had instead done this? 1 plus 2 is 3. That's 1.5. 3 plus 4 is 3.5. And I added all of these averages up. Let's just do it right now. The next one's going to be 5.5, 7.5, 9.5, and 11.5. And if I add all of those up, I've got 1, 3, 5, 7, 9, 11. The sum of the first n, the sum of the first n odd numbers, this is the 6th odd number, is n squared. So the sum of the first n odd numbers is n squared. 11 is the nth odd number. And I can see you might be thinking, but what about all the 0.5s? You ignore those. We're just going to separate in our mind. It's no different than 1 plus 0.5, and I'm only focusing on this. Now, if I add the other 0.5s, what do you notice? You get 3 more. It's still going to be 39 if I do the average of any 2 numbers. This is kind of a fascinating thread to pull. Maybe you can explore it more after class and see what you can find out. The best problem solvers are typically explorers. Not much to add here. Literally, the volume of a cube is what we mean when we say x cubed. That's what it is when you cube things, okay? So if you can tell that there's 6 of these and each of them is 3, then their edge length is root 3, which means you have root 3, root 3, root 3. Okay, let's go up a little bit here. Don't have much to add to 7. Number 6, let's do it with another method really quick as well. If we had focused on remainders, like this is something you'll learn in Intro to Number Theory. The textbook from AOPS is the one that I prefer. You can try and learn it other ways too. The remainder when you divide 15 by 4 is remainder 3. The number when you divide this is remainder of 0. The number 17 is remainder 1, 18 remainder 2, and 19 is another remainder 3. What you need is the sum of the remaining, this is going to sound funny, the sum of the remaining remainders needs to be a multiple of 4. So if you add up the remainders right now, 3, 6, 7, 8, 9, getting rid of the one that's remainder 1 leaves remainder 8. Nothing else will work, and you know that nothing else will work. How do you know? Because if something else also worked, there would be 2 different answers, and 2 different answers would make the question invalid. So if you find one that works, removing the remainder 1 term, which is 17, that's another way I thought about doing it. But because I just, 85 and subtracting this number was really quick, and since all of these are just one more than 15, I'm not actually doing this in my mind. Not that it's hard, but because you subtracted 15 and got to 70, subtracting 16 is just going down one. And from there, it's just a matter of saying 69, 68, and so on. And 68 is a multiple of 4. It's 4 times 17. A really good idea I teach all of my students is to be able to instantly prime factor every number under 100. It should be instantaneous. You do not think about these things. They are automatic, just like your times tables. Okay, so this is things to do as far as goals if you're preparing for the competition. And you might say, why would I need to do that? Because the best students in the country can do that, and that's who you're competing against. So you're trying to increase your level and your skill set so that you can calculate things faster. Slow down when you read. Calculate faster is kind of my recommendation to pick up your speed improvements. There's not much to add to this. Like if you go this way, 2, 3, like I see it's 2, 1, 1, 2, 1, 1, 1. All of these are going to have the same thing. Basically, if you have done block pathing in probability, I call it block pathing. I have a video on my channel. It's a live stream that I did a lecture on this concept. I call it block pathing. It's really just paths on a grid is what maybe AMC calls it. If you have this rectangle and you're going from A to B, then you're going to be going the same number of moves. You have to go down 3 no matter which way you go and right 1, 2, 3, 4, 5, 6, 7. So you're going right or left, actually, in this case, left 7. So down 3 and left 7 is 10 moves. It doesn't matter where you make those moves. In the counting and probability book, you'll learn that you can combine these into a combination 10 choose 3, which is the number of paths that you can take to go from A to B. Okay, but we're not even counting the number of paths here. We're just finding the shortest distance, and all the distances are the same. They're all going to be 10 moves between A and B. So I can do that quickly because I'm familiar with the background concepts. Okay, this one here too, something else we might have done, you could have created an nth term formula. The nth term is the first term plus n minus 1 times the common difference, -7. This will give us 107 minus 7n. So if n is 1, what do you get? 100, the first term. We could have done this. We could have then taken the 10th number, dropped the 10 in to get 70, and 107 minus 70 is 37. This is, in my opinion, the hardest one of the first 10 because of Annika and 3 of her friends. It comes very early in the contest when you're kind of still getting warmed up, and they know that, and they put that there and wrote it precisely in this way and put the corresponding answer just to create a trap answer for the students. So this is why you got to be very careful with the reading. Don't just read and you skim read is okay, but also go back and verify there's nothing weird happening. I'm sure a lot of people made that mistake. Nothing to add to number 2. It's really just pretty straightforward. This one's really surprising that it's 50%. It doesn't look like 50%, but you can verify too, right? If you had to, say you just doubted yourself, count the white portions. There's 4 corners, 1, 2, 3, 4, plus this is basically a square, as is this, as is this, as is this. So the white part is also 8. You can have high confidence that it really is 50% of that grid. Okay, let's continue on from this point. So we got through number 10 in a pretty good time, 6 minutes, 44 seconds. I'm going to go back now and continue from number 11 at this is the speed I would solve at on the contest, but I am maybe a little bit slower than I would be on the contest because I'm stopping to explain some of my reasonings to you. Okay, number 11, a tetromino consists of 4 squares along their edges. There are 5 possible, got it, which can be rotated, flipped. 3 are used to complete a 3x4 rectangle, which can be rotated or flipped over. There's always 4 squares, okay? So at least one of the tiles is an S tile. Now, the fact they say at least one means more than one could be an S tile, but in the answers, there's not that, so we don't have to worry. What are the other 2 tiles? So, but the fact that they say at least one is it can be used more than once. It doesn't say that anywhere else. But you can kind of assume it based on the fact that it says that. So if I put it right here, gonna have a problem with the one empty square. So what I'm gonna do is erase that and move it up one and try it right here. And now what might I fit that has a block of 2? I wouldn't be able to use that. I can't use that. I could really only use an L shape here. So L like this. So there's only 3 from the backside. And look, another L, L and L. Okay, so L and L is it. Number 12, the region shown below consists of 24 squares each with side length 1. What is the area in squares, the largest circle that can fit inside the region, possibly touching the boundaries? My gut instinct says go like this. And if I try that, now what I'm looking at is there's a little gap right here from that corner to where it is. This circle could technically expand out until it's hitting that gap. If I use this, it's 4 pi, but we're not fully expanded out. There's room for growth. Like this end can go out farther, that end could go up, and this corners right here could go through that corner. So it's probably not that. Let's check it here if I go through these corners here. Like this. Okay, so I've got a center here. Now that would be my farthest out point right there, or here. And that's going to be 2, 1, root 5. Root 5 is 5 pi. Satisfied. Okay, keep going. Number 13. Each of the even numbers, even 2 to 50 divided by 7, remainders are recorded. Histogram displays the number of times each remainder occurs. I don't even know how to begin. I guess 0, 0, 0 has always 3, but now it has 4 and 4. So how many multiples of 7 are there that are even? The first one's 14. Zero's not included. Double check. 14, 28, 42. That's as high as you can get. There's 3. It's neither one of these. Next up, let's try, I don't know, I guess 6, remainder 6. If I do remainder 6, the first one is 6. It's 0 times 7 plus 6. But the next remainder, if you did number theory, is going to be 14 away. Why not 7 away? Because it's not even. So 6 and I add 14, now we're at 20. So you have 6, 20, add 14. In fact, can I add 42? Yes. 48 would be my last number. 34. There's definitely 4 of these. C is out. That one's got 4. That one's got 4. What else might I try? I've got 4 and 3 on the 3s. That looks different. Or I could do the 4s. I don't know. Let's just do 3s. Remainder 3. 3's not going to be in there. But if I add 7 to that, 10. Adding 7 keeps the same residue or remainder class. So 10's got a remainder of 3. Can I add from 10, 42? I can't. So there should only be 3. If I add 14, 24, add 14, 38, add 14, 52. And 52 is too big, and 10 plus 42 is 52. I do those kind of double checking my calculations. There are exactly 3 with a remainder of 3. Therefore, the answer is A. Clear, clear, go. Next one, number 14. A number n is inserted into the list. 2, 6, 7, 7, 28. The mean, which is the average, is now twice as great as the median. So what's the median? It looks to me like our current median is 7. If I put n on the right side, the median will become the average of the 7s, which is still 7. If I put it on the left side, it would become 6.5, the average of 6 and 7, or the average of n and 7. Since the left side's weirder and the right side is more confident, I'm going to try the right side first. Okay, so assuming that the median is 7, I would need the mean to be equal to 14 after I insert n. I've got 30, 14, and 6 is 20 more. That's 50. 50 plus capital N divided by, there's 5 here. When I add n, there'll be 6. That's 14. 60 and 24 is 84. N 34. It's there. Answer choice E. Clear, clear, go. Just double checking though really quick. 30, 14, and 6, 20 more is 50. The mean is now twice as great as the median. Median really is 7. 34 keeps that happening. That checks out. I don't really see much else we can do. If you find one that works, again, if another answer also worked, the question would be invalid, and we didn't violate any rules. I'm going to stick with that. Kai draws a 6x6 grid. He colors 13 of the unit squares. So 6x6 is 36. Of those, 13 are silver. and the remaining square is gold. So he's got 23 gold. Sounds a little bit like, who's that swimmer? I don't know, the famous swimmer in the 123 gold medals, I think. Can't think of his name right now. And maybe it's 24, I don't know. Anyhow, Kai then folds the grid in half vertically, forming pairs of overlapping unit squares. Michael Phelps, that's what I'm thinking of. Overlapping unit squares. Let little m and big M equal the least and greatest possible number, so it doesn't have to happen, gold on gold pairs. What is the value of their sum? So basically find the least and the most. If I wanted the least, I want all 13 of these silver to be paired with the gold. So if all 13 silver take out 13 gold, you have only 10 gold remain. Now, how do we know all of these are on the correct side so that they can be paired up? They have no choice. It doesn't matter where they're located. I couldn't have 10 empty squares over here and 0 on this side. That would be impossible. Otherwise, the 13 silver would not have paired with 13 gold. The pairing implies they're on either side of the line. So you have 13 on the left, 13 on the right in any capacity. We don't even have to do it. There's 10 gold remaining, which means there's 5 gold on gold pairs. So little minimum M is 5. The maximum would be what? If I wanted the maximum number, I don't want to undo that. I would want my silver to be matched with silver as much as possible. So of this 13, 6 with 6 would get rid of 12 silver and leave 1 silver remaining. So that 1 silver would take out one of these 23 gold, leaving 22 gold. And they'd have to be split evenly on either side to create this pair. So for example, 7 silver here, 6 silver here. There's 1 silver remaining that does not pair with those 6. It's going to take out a gold, leaving 22, meaning you've got 11 gold on gold pairs. 11 plus 5, 16. Answer choice C. Number 16, 5 distinct integers from 1 to 10 are chosen, and 5 distinct integers from 11 to 20 are chosen. So 5 distinct means different. No two numbers differ by exactly 10. So if I have 1, I don't have 11, and vice versa. What is the sum of the 10 chosen numbers? Again, there cannot be more than one sum. All I have to find is a scenario that fits this criteria. I'll take 1 through 5, which means that's choosing 5 from this set. I cannot have 11 to 15 here. I must have 16, 17, 18, 19, and 20. 1 and 20 is 21, 2 and 19, 3 and 18, 4 and 7, all 21s. 21 times 5, 105. C. What is the sum? That's it. Good. Okay, just double checking. 17, land of Markovia, like a Markov chain. There are 3 cities, A, B, and C. There are 100 people who live in A, 100 in A, 120 in B, and 160 live in C. Everyone works in one of the 3 cities, and a person may work in the same city where they live. So again, slowing down reading at these points because it's very verby and wordy and stuff like that. So in the figure below, an arrow pointing from one city to another is labeled with the fraction of people living in the first city who work in the second. 1/4 of the people who live in A work in B. Really quick note, don't read stuff like this. Look at it with your eyes and don't say it. You're trying to save time on your reading. Obviously, you can recognize it says, for example. No need to pronounce those words in your mind when you're going through. 1/4 of the people who live in A work in B. So that's what this arrow means. That makes sense. How many people work in A? Okay, so now if 1/4 of A works in B and 1/5 of A works in C, because we're focused on city A, that would mean 1/4 plus 1/5 work in another city. 5 up to 1 is 5, 4 up to 1 is 4, product of 4 and 5 is 20. That's 9 over 20. So 9 over 20 of A work in a different city, which means 11 over 20 of A work in A. I'm curious if this is a trap answer if you didn't recalculate. 11/20ths of 100 times 100. 20 at 100 gets 5. 11 times 5, 55 from A work in A. This is the amount that work in other cities. Double checking my thinking. 55 then work in A. Okay, so now it would have been 45, by the way, if It had been the other cities on that calculation. Just want to keep that in mind in case we're off by 10. I want to check for trap answers. So 120 live in B. Okay, well, I just have to look then at the arrow of B going to A, which is 1/3. 1/3 of 120 is 40. This arrow goes to C. It's not like it passes through C or something weird like that, works in both. We don't have to worry. There's only one arrow. Double check. There's only one arrow going out of B to A. There is. From C, there's only one arrow going out to A. 1/8 of 160 is 20. So 40 and 20 is 60 and 50 is 110, 115. Good thing 105 is not there. You wouldn't have gotten trapped if you lost 10. But answer is D, 115. Clear, going on. 18, the circle shown below on the left has a radius of 1 unit. The region between the circle and the inscribed square is shaded. In the circle shown on the right, 1/4 of the region between the circle and the inscribed square is shaded. The shaded regions in the two circles have the same area. What is the radius R here of that? Okay, so first off, the diagonal of the square is 2. That means that this is root 2 here. Or we can use the fact that a square is an orthodiagonal. That white square has 1/2 the product of its diagonals, which is going to be 2. Now, what is the circle's area? Since the radius is 1, it's pi 1 squared, which is just pi. Pi minus 2 is that region. But they said, what about the shaded regions? They are the same area. I can use the same trick here. The area of this circle is pi times big R squared minus, I can do 1/2 times 2R times 2R because it's an orthodiagonal. And then I have to divide that by 4 because that would have included all of these regions here. But we don't want the other 3. We only want one of them. So it's like it says 1/4, 1/4 of the region. Perfect. So now I'm just going to go ahead and multiply by 4. Or should I first yet? Let's see what this comes out to. Yeah, I'm going to multiply by 4. So 4 pi minus 8 equals, over here I've got pi r squared minus the 1/2 and the 2 cancel. There's 2 r's and a 2. It's 2r squared. Picture the r squared factored out. Pi minus 2 remains. We had a 4 over here. If I divide by pi minus 2, that 4 reappears. And I've got 4 equals capital R squared. In other words, take this, factor out R squared, and it's going to equal, not, hold on. It's going to be 4 squared times pi minus R. And I should have just kept that factored out. Pi minus 2. I'm sorry, not pi minus R. Pi minus 2. And then this cancels that. And since pi and 2 are constants, we don't have to worry about any weird things happening with the cancellation. Therefore, capital R is 2. What is the radius? 2. We're done. Answer choice B. Okay, moving on, number 19. Two towns, A and B, are connected by a straight road, 15 miles long. 555. I like to process as I read. Traveling from town A to town B, the speed limit changes every 5 miles. So 25, 40, and 20. It tells you that same thing. Two cars, one at town A and one at town B, start moving towards each other at the same time. They drive at exactly the speed limit in each portion of the road. How far from town A in miles will the two cars meet? Let's just see what would happen. If you're driving 25 miles per hour for 5 miles, then you're taking 1/5 of an hour. So rate times time equals distance. Rate 25, time we don't know, distance 5. Then your time is 1/5 of an hour because it's in miles per hour. So if it's 1/5 of an hour, this took 12 minutes for A to get to right here. Now I'm going to have B advance to the same spot on theirs. How long will it take them? Same thing. Distance divided by the distance is 5 divided by the rate will be the time in the same way. So it's 1/4 of an hour. So B is not going to get here until the 15-minute mark. My idea is to advance time forward to a time when they're both on this part of the road. So if this gets here at 12 minutes, that means car A is going to drive for 3 minutes, which is 1/20th of an hour. So your rate times your time equals your distance. 1/20th of an hour is your time because there's 3 minutes until the 15-minute mark. That's when B is going to arrive at this change in speed. So rate is 40 for A for 1/20th of an hour. That means they're going to go a distance of 2. So at the 15-minute mark, I'm going to get rid of this 12. At the 15-minute mark, A is now right here and B is now right here. We'll call it A prime and B prime. This is 2 miles. So they've gone 7 miles. Now they're on the same patch of road, and they're traveling the same speed, which means they're going to each cover half of this distance. Let's verify that. I just don't, it seems logical, but I don't want to trust myself. If my combined rate of the two cars is, they're collectively covering 80 miles per hour, collectively. They're moving towards each other at that rate collectively, adding their two distances. Then their time, we don't know, but they have to go a distance of 3 miles. So their time will be 3/80ths of an hour. Now, if I go back and I do just car A traveling 40 for 3/80ths of an hour, the 40 and the 80 will cancel to give 2. A will go 1.5 miles, B will go 1.5 miles. It makes sense. I just had to verify to be sure. So just can't take chances. So 7 plus the 1.5, 8.5 miles. How far from town A? In miles, 8.5 is the answer. Moving on. Number 20, Sarika, Dev, and Rajiv are sharing a large block of cheese. They take turns cutting off half of what remains and eating it. First, Sarika eats half the cheese. Lucky her. Then what remains is 1/2. This is what remains. Then Dev eats half of what remains. So that means Dev eats 1/4, but that means 1/4 remains. So Dev's going to eat 1/4. Think about how much did they eat right now. 1/2 plus 1/4 is 3/4. That means 1/4 remains. So it looks like whatever a person eats is also what remains. That checks out with Sarika because she ate a half and a half remained. Okay, now that we're satisfied with that concept, we're going to advance forward with it. Then Dev eats half of the remaining half. Rajiv eats half of what remains, 1/8. And then back to Sarika, who eats 1/16. This is going to be an infinite geo. They stop when the cheese is too small to see, basically infinitely small. About what fraction of the original block of cheese? About, notice it says about because it's not going to be a perfect infinite sequence, but it's close enough once you can't see it. It's so small it won't contribute much to the total amount. So we can treat it as if it was infinite. She eats a half and then 1/16. 1/2 plus 1/16 plus ... You're looking for infinite geometric series sum, which is the first term divided by 1 minus the common ratio. Your common ratio is any term divided by the previous term, that, or what you multiply by. You multiply by 1/8. And 1/16 over a half is 1/8. So my a sub 1 is going to be 1/2 over 1 minus 1/8. I will now multiply numerator and denominator by 8. 8 times a half is 4. 8 times 1 is 8. 8 times 1/8 is 1. So 8 minus 1, 7. 4 over 7. Answer 4/7. Sarika, got it. She was the first one, double checking. 4/7 is going to be that answer. Königsberg is a famous problem. I think it usually cover it in discrete math called the 7 bridges of Königsberg. And I think it looks a lot like this, in fact. It might even be the exact same, maybe. I don't know. I don't remember. It has assigned grades 1 through 7 to pods A through G. 1 grade per pod. Some of the pods are connected by walkways, as shown in the figure below. Okay, grades 1 through 7. Some of the pods connected. Okay, got it. The school noticed that each pair of connected pods has been assigned grades differing by 2 or more grade levels. So, for example, grades 1 and 2 will not be in pods directly connected by a walkway. What is the sum of the grade levels assigned to pods C, E, and F? If I just take a guess and see how this works, if I have 1 here, 2 could not be in G, F, or B, or C. Maybe I could put 2 over here, or I could put it here. Just randomly, I'm going to try this out. Now, this, maybe I could make it 3 because it's 2 away. Can't put 4 here, but I could put 5 here. Problem is, where's 4 going to go? Because 4 cannot go here, here, here. This doesn't work. We're going to have to come up with a strategy and think about which, like G and D seem like great. They're restricted connections. So I don't have to worry about them. Let's look at what has the most connections. F seems like it has a lot. 1, 2, 3, 4, 5. So if I think about the numbers 1, 2, 3, 4, 5, 6, and 7, and I try 3, there are 2 numbers that 3 cannot connect with, leaving only 4 that it could. So I would not want to put 3 in F because there'd be no way to set it up. So let's say, what about 1? 1 has only one thing it can't connect with. I'm going to need it to be 1 or 7 at F. I think that's the strategy, is to isolate terms. I'm going to try and put 1 right here. Are there any other places that are connected to a lot? 1, 2, 3, 4, 5. C has the same problem, which means the other side of my list, 7, should go in C. Okay, so because 7 can only connect to 6, the only place that it could connect to is not connect to is over here. C connects to A, to B, to F, to D, and to E. That's the only one it doesn't connect to, and that's why that one has to be a 6. Okay, so now that I've got that, I probably could switch 1 and 7 as my guess, but we don't know for sure. And it won't matter because we're looking for the sum of the grade levels assigned to these 3. So where could 2 go now? 2 can also go to the only pod that 1 doesn't connect with. Let's place 3 maybe over here, 4 here, and 5 here. Does that work? 5 is not connected to 6. 5, let's just go through one at a time. 1 doesn't touch 2. 2 does not connect to 3. 3 does not connect to 4. They're on opposite sides. 4 does not connect to 5. 5 does not connect to 6, and they don't connect. This is it. 7, 8, 12. Sum, 12, 12's there. Answer choice A. I still don't trust myself. 4 and 5, 5 and 6, 3 and 5, 3 to 7, 6 and 7. I don't know, panic kind of, I think it's going to be right, but still. 7 doesn't touch 6. 6 does not touch 5. It really has to be this. I'm going to go with 12. Okay, continuing on. 22. A classroom has a row of 35 coat hooks. Paulina likes coats. We got 10 minutes left. To be equally spaced, that there is the same number of empty hooks for the first coat, after the last coat, and between every coat. So if I have one coat, suppose there is at least one coat and at least one empty hook. I'd have to have empty hooks, one coat, and then empty hooks, which means I would need these 2 empty coats or empty coat hooks to add up to 34. That's possible. We could call it 17, 1, 17. How many different number of coats can satisfy Paulina's pattern? So if coats equals 1, that works. How can we make this an efficient process? Let's just say I had 2 coats, so I'd have to go empty. I'm going to just put coat, empty, coat. Coat 1, coat 2, and empty. I need the empties to be equal, right? Same number of empty hooks before the first, after the last, and between every coat and the next one. There has to be at least one empty hook. I was just thinking, what if we had all coats, but we can't have that? So that takes out that thought. I need these 3 empty coat hooks to add to whatever's left after I subtract 2 from that. So maybe I can think of it as 35 minus the number of coats. Notice that the number of empty coat hooks is coats plus 1. So empties equal to coats plus 1. I think I can use this. Let's just try plugging in values for C. I would need integers. If C is 2, I have 33, and this would be 3, and 33 is divisible by 3 to give 11. So I'd have 11, 1 coat, 11, let's look at the slash mark, 11, and then 1 coat, and then 11. And that works. 11, 11, 11, subtract these 2. The number of empty regions is always 1 more than the number of coats. Does it say that they are equally spaced, the same number of empty hooks before the first coat, after the last? Yes. So she has to have at least, there cannot be 2 coats together in the same spot. You can't put 2 coats in the same hook, so I don't have to worry about that either. I think this is a good setup right here. So now we have coats as 1 or coats as 2. Let's go to the next one. Let's try if coats is 3. If I do 35 minus 3, I'm at 32. 3 plus 1 is 4. That gives 8. Just to double check this is still working, I don't trust myself, I would need 8 empty coat hooks, 1 coat, 8 empty coat hooks, one coat, 8 empty coat hooks, one coat, 8 empty coat hooks. 8, 8, 8, and 8 is the 32, 1, 2, 3 coats. It works. This is a good process. I'm satisfied with it now. I just have to run a couple tests on my methodology. So now, oops, put that back, C plus 1. So now if C is 4, I get 31, which is prime, not going to work. If C is 5, I get 30 over 6. That's going to work. C can equal 5. If I do C is 6, I get 29. 29's prime, not going to work. If I do C is 7, it's 28, but that's 8. That's not divisible by 8, so C is 7 does not work. If I do C is 8, I go down to 27, and that's 8 plus 1 is 9. That's going to work. C is 8. That's an acceptable value. If C is 9, I'm at 26, but that's 10, not divisible. 26 not divisible by 10. If C is 10, I'll be at 25, and that's 11, not going to work. If C is 24, or not, sorry, if it goes down to 24, making C equal to 11. So C is 11, 35 minus 11, 24. That becomes 12. 24 over 12 is a check. That works. So C could equal 11. What I'm noticing is that if C goes up any higher, I don't think we're going to find any. I don't think. So let's just see. If I take 12 down, 35 minus 12 is 23, and then divided by 13. Obviously, this is more than half of every remaining number, but could it ever equal 1? Is there a scenario where it could equal 1? Looks like I'm going like this. You're going down 1, up 1. These two numbers then add to 36. So maybe I could do 18 over 18. Then that would be if C was 17. So C 17, 35 minus 17 is 18. 17 plus 1, also 18. Now, does that actually work? Is there any violations with it? How many we have right now? We have 1, 2, 3, 4, 5. We're in no man's land. It has to work. It's going to have to be 7. I don't even have to verify because there is no answer of 6. So we've got that. Clear, go on. I've got 5 minutes. How many 4-digit numbers have all 3 of the following properties? 10's digit and 1's digit are both 9. Okay, so ends in 99. The number is 1 less than a perfect square. That means it has to end the perfect square. This perfect square has to equal something that ends in 100. So you're looking for things like 20 squared, that's only 400. 30 squared is 900. 40 squared is 1600. 50 squared is 2500. 60 squared is 3600. 70 squared is 4900. 80 squared is 6400. 90 squared is 8100. 100 squared is too big. These are possible candidates for the perfect square that is one more than our number. The number is the product of exactly 2 primes. There's a thing I call Farmer's Friends principle. Farmer's Friends principle works like this. If you do, like let's say I had 2 numbers that are a perfect square, like 40. If I go down 1 and up 1, the amount over here will drop by the square of the gap. I call it Farmer's Fence principle. Take my class. I will go over that more in detail in there. So 39. So 18 and 22, the gap is 2. It will go down by 4, the square of the gap to be 36. So I'm sorry, not 400, 399, and 396. 400, 399, 396. So it goes down by 1. This goes down by 4 because the gap is 2. So in the same way, I'm going to need this situation to create something ending in 99. So if I take 40 squared, it would be 39 and 41. Are those both prime? No, 39 is not. Is 50? 49 is not prime. No. Is 60 going to work? I have to go down 1 and up 1. Those are both primes. Know all of your primes less than 100. There's 25 of them. So that's one set. This is 70, so you'd go down to 69, which is 3 times 23, not going to work. 80 is going to go down to 79 and 81. 81's not prime. 90 is going to go down to 89 and 91. 91 is 13 times 7. There's only one case. It's B. That's it. 24, in the trapezoid ABCD, angles B and C measure 60, and AB is equal to DC. Okay, so I'm thinking right now, my gut says drop an altitude right here and drop an altitude here. Why would I do that? 30, 60, 90. Call this B and B. these will also be equal in an isosceles triangle. And as a result of 30, 60, 90, the hypotenuse is going to be 2x and 2x. We don't know what the height is. We could find it. It would be x rad 3 based on 30, 60, 90. The side lengths are all positive integers, okay? And the perimeter is 30. I'll then add the perimeter. 2b plus 3x and 3x is 6x needs to equal 30. Immediately divide by 2, maybe. I don't know. B plus 3x equals 15. What are we doing? What's the plan? These are things that might be useful. How many non-congruent trapezoids satisfy all three? So if I want to do this, let's say x was 5, that would make b 0. If that happened, you'd have an equilateral triangle. That won't work. So x cannot equal 5, but x could equal 4. That would give me 12. So probably 4, 3, 2, and 1. The reason is I need to keep some positive value here. I can't let b be all 15 of it either. If x was 0, you'd have a rectangle. It would look like this. So in fact, you wouldn't even have, I don't even know how you would do that. So yeah, that wouldn't even work at all. So you've got to have, x has to have some value, 1, 2, 3, and 4, and that's all we got, E. We got 2 minutes. Let's keep going really quick. Michaela finds all the possible ways to draw a path in a 5x5 diamond-shaped grid. Each path starts in the bottom of the grid and ends at the top, always moving 1 unit northeast. That's this way, or northwest that way. She computes the area of the region between each path and the right side of the grid. 2 examples are shown in the figure below. What is the sum of the areas determined by all possible paths? Wow. Okay, so there's one path that has all area and there's one path that has no area. I bet there's symmetry involved. What if we went here and we cut off, let's clear out the screen. What if I went here, I cut off 1 square? There's only one way to do that. And there's only one way to do the one over here. So this would give me an area of 24. That would give me an area of 1. The other one was 0 and 25. There is symmetry here of some kind of like a dice problem. Think about this too. I've got 9, 11 here, and this is going to be 14 over here, and that's 11. So the number of ways to create a path that had 14 on the left, we're not going to get this in time. There is some kind of symmetry. I'll try and solve it afterwards, but we wouldn't get it in time, although I am talking and explaining things as I go. Let's just see if we can figure it out. Okay, so I would say there's 1 way times 25. How many ways are there to leave 1 square empty? Also 1 times 24. How many ways to leave 2 squares empty? So if I leave 2 squares empty, I could go like this and make it those 2, or I could go like this and make it those 2. There would be 2 ways to leave 2 squares empty, which is 2 times 23. That means there will be 2 ways to include only 2 squares, right? Something like over here, if I went, cut off those 2 squares so that only these are shaded, there's also 2 of those. So I would have 1 times 25 plus 1 times 0, meaning that this and this are always 25. I would also have 1 times 24 plus 1 times 1. Notice again a sum of 25 and 1. And there'll be 2 ways to get a 23, and there'll be 2 ways to get a 2. I just don't know how to capitalize on it. We're always getting a sum of these 2 of 25, and they always have the same number of paths. Well, since they have the same number of paths, if we can take the total number of paths, wouldn't it have to be equal on both sides of this with sums of 25? We have all the numbers from 0 to 25 inclusive as possible areas, and they're all paired up. So 0 with 25, 1 with 24, there are 26 area possibilities from 0 to 25, and they're paired up. So because they're paired up an equal number of each, and there's symmetry, meaning, again, the number of ways to leave, what is this? 11 on this side is the same as the number of ways to leave 11 on the other side, because the shapes are the same. It doesn't make sense that you wouldn't get a symmetric effect like that. So if I could pair up the areas, any area of 14 corresponds with an area of 11 that's not shaded. And again, the sum is 25. 26 area possibilities. I think we just need to count total paths to the top. This goes right back to combinatorics. You're going to have to go right 1, 2, 3, 4, 5, left 1, 2, 3, 4, 5. There are 5 L's, 5 R's, and you're going to choose 5 ways to arrange those letters, each one corresponding with a different path. So 10 times 9 times 8 times 7 times 6 over 5 factorial. I'll put 5 times 2 here. I've got 4, 3, 4, 3. I guess we'll put 3 here under the 9. Okay, so this cancels the 10, 3 cancels the 9 to give 3, 4 cancels the 8 to get 2. I've got 36 times 7, 7 times 40 minus 4, 280 minus 28, 252. So there are 252 paths. 252 total paths. How do we use it? We have to pair those paths up. But how do we, since the area always adds, we have to have an even split. Okay, so if I add the white part and the gray part, the total is 25 every time. And there's 252 total paths, which means I'm pairing up a white area with the gray area. So like white area plus gray area equals 25. And I'm pairing them up. Has to be 126 pairs of paths. And the sum of the areas of both, kind of like when we had the 24 plus 1. This is 24 good gray area, and this was good. That means the sum of these areas paired up is 25. I think we can just do this. 126. 126 times 25. Because that's 5 to the third plus 1, and that's 5 squared, I can do 5 to the fifth, which is 3,125, and then add 25. It's probably 3,150. We are out of time. I will check that answer really quick. Let me pause and pull up the answers. 2025 AMC 8. I'm not going to have a chance to go through all of these, but we can verify some. I'm pulling up the answers right now. Resume share. It was B, and we got B, didn't we? Pause this. Don't care. It is B. Good. Okay. Wow. I don't know if I would have got it in the right amount of time, but again, maybe if I'm not explaining. 24, we had 4, which was E. That was right. 23, we had 1, which was B. That's right. 22, we got 7, which was D. That's right. 21, we had A, and it is A. 20, we had A 4/7, and the answer is A. 19, we had D, which was 8.5. Wait. Well, what did we have? We didn't have D. We had 8. Let's see. 19 was D. Oh, yeah, it was 8.5 because we had 7 on the A and we added 1.5. Good. And then 18, we had 2, which was B. 18 is B. 17 is supposed to be D. That's what we got, 115. I'll let you guys check the rest. I'm pretty confident in the rest. 16 was C. And we got 105 on that one. I think so. 11. Wait. 5 distinct numbers. Yeah, it's 21 times 5 we had for that. On the paired grid one, I think we got 16. 15 was answer choice C. 14 was E34, and we got 34. 13A, and we got A. 12, we had 5 pi, which was C. I'm confident in the rest. I think they're going to be good. Hope you enjoyed it. If you enjoyed the content, if you have any questions from it, leave a comment down below. I try to answer all my comments when time permits, and if I didn't get to yours in recent times, I do apologize. I'm not always able to sit at my computer and answer questions, but I will try to get to it eventually. Just be patient. If you're interested in classes, reach out to me through my website or my channel email. They'll be linked in the description of this video. Good to see all of you. Hope you're enjoying the start of your summer.